Today, I am going to solve the numerical problems from the chapter 7 titled Work and Kinetic Energy. So these 5 problems today I am going to solve, and these problems are taken from the book The Principle of Physics 10th edition. First question. When accelerated along a straight line at 2.8 10 to the power of 15 meter per second square in a machine, an electron of mass 9.1 10 to the power of minus 31 kilogram has an initial speed of 1.4 multiplied by 10 to the power of 7 meter per second, and it travels 5.8 centimeter. So what is given in the question? You are just accelerating the electron at a rate of 2.8 multiplied by 10 to the power of 15 meter per second square, and which has the constant mass of 9.1 multiplied by 10 power minus 31 kilogram, which has the initial speed of 1.4 multiplied by 10 to the power of meter per second. By that, it covers the distance of 5.8 centimeters. So first of all, I'm going to write what are the things given in the question. Given the acceleration of the electron is given as 2.8 multiplied by 10 to the power of 15 meter per second square, and then the distance travel is given, which is delta x I'm going to take. So 5.8 centimeter, which I have to convert it to the meter. So you have to divide this number by 100. So by that this number becomes 0.058 meter. And the mass of the electron is a constant value 9.1 multiplied by 10 to the power of minus 31 kilogram, and then it has the initial speed. What is the initial speed here? 1.4 multiplied by 10 to the power of 7 meter per second. So these are all the informations given in the question. Now we have to read what we are going to find. So this question has two subdivision. In the first part, we are going to find what is the final speed. So if the electron is accelerated with the initial speed, means it must have the final speed. And second one, we are going to find the increase in its kinetic energy. That means we are going to find what is the change in kinetic energy. So we know the formula for change in kinetic energy, which is final kinetic energy minus initial kinetic energy. So if you want to find the change in kinetic energy, this final speed is very important. So first I am going to find what is the final speed by using the concept of our previous chapter, especially the chapter 2. We studied the three equations, the equations of motion with constant acceleration. So first of all, I'm going to find the answer for the first part. For this, I'm going to use the third equation. What is our third equation? We studied these three equations. V, which is equal to V naught plus AT, and delta X, which is equal to V naught T plus half AT square, and third equation V square, which is equal to V naught square plus 2 into A into delta x. So these three equations we already studied in the second chapter. Now we have to identify which equation is exactly fit for finding the value of the final speed. So if you want to use the first two equations, it's not possible because in this question the time value is not given. So the first two equations is not possible. So what I'm going to do, I'm going to use the third equation. What is our third equation? Our third equation is V square, which is equal to V naught square plus 2 into A into delta x. So I'm going to write this equation. So V final square, which is equal to V initial square plus 2 into A into delta x. So now I'm going to substitute the value V final square, which is equal to our initial speed is 1.4 multiplied by 10 to the power of 7 the whole square plus 2 into A. What is our acceleration? Our acceleration here they given as 2.8 multiplied by 10 to the power of 15. So the acceleration of the electron is 2.8 multiplied by 10 to the power of 15 multiplied by the delta x value is 0.058. So I have to take the square root on both sides. So by that, this equation will become Vf, which is equal to square root of 1.4 multiplied by 10 to the power of 1.4 multiplied by the 10 power 7 the whole square plus 2 into 2.8 multiplied by 10 power 15 multiplied by 0.058. Now I have to calculate the final speed. Square root of 1.4 multiplied by 10 to the power of 7 square plus 2 into 2.8 10 to the power of 15 multiplied by 0.058. So what is my answer? 22821042. So I have to write. So this is my answer. 22821042.92. So I can write this number as 2.28 multiplied by 127 10 to the power of 7 meter per second. So this is my final speed. Clear? So once we found the value of this final speed, it is very easy to find the value of the change in kinetic energy. So now we have to come for our second part. So what is our second part? We have to find what is the increase in its kinetic energy. That is nothing but what is the change in kinetic energy. So what's the formula for change in kinetic energy? Kinetic energy final minus kinetic energy initial. As we already studied the formula for the kinetic energy, which is half mv square. So I have to write half mv final square minus half mv initial square. I can take half m outside as a common term. So inside the bracket I can write v final square minus v initial square. So clear? Now I'm going to substitute the value here, as we already found the value of this final speed here as 2.2 multiplied by 10 to the power of 7, and the initial speed in the question they given as which is I think 1.4 10 to the power of 7. So better we can have a look of the initial speed. The initial speed is 1.4 multiplied by 10 to the power of 7. I'm going to substitute the value here. Half the mass of the electron is 9.1 multiplied by 10 to the power of minus 31, and just before we found the value of this final speed, which is 2.28 multiplied by 10 power 7 square minus 1.4, which is initial speed 1.4 multiplied by 10 to the power of 7 square. So if you get confused, better put a small bracket. So now we have to find the value of the change in kinetic energy. What is the change in kinetic energy? Change in kinetic energy, which is equal to 1 over 2 1 over 2 multiplied by 9.1 multiplied by 10 to the power of minus 31 multiplied by the initial final speed 2.28 10 to the power of 7 square minus 1.4 10 to the power of 7 square, which gives the answer of 1.47 multiplied by 10 to the power of minus 16. What's the final answer? 1.47 multiplied by 10 to the power of minus 16, and the unit for the kinetic energy is joules. So this is the answer for the second question. Clear? So in this question we have two subdivision. The first part we found the value of the final speed, and the second part we found the value of the change in kinetic energy. So this is the procedure how to solve. Okay. Now we have to come for the second question. So read the questions line by line, word by word. A particle travels through the three-dimensional displacement, which is given by the displacement vector d, which is equal to 5 I cap minus 3 j cap plus 4 k cap, which is in meter. If the force of magnitude 22 Newton and with a fixed orientation work does on the particle, find the angle between the force and displacement. So that means in this question, they give the force in terms of magnitude, but the displacement equation is given in terms of vector form. So what we are going to do, we are going to find the value of work done by the external force. Clear? As we already know the formula for the work done by the external force. What is the formula? Work done, which is equal to FD cosine theta. This is the rule. But I can't use this value directly because here we have the value of the force in terms of magnitude, and but the vector, the displacement is given in terms of vector form. So what I'm going to do, first I'm going to convert this vector form into magnitude, and we already studied this formula in chapter number 3. Am I right? So better we write the given first. The force of magnitude, the magnitude of the force is given as 22 Newton, and the displacement vector is given as 5 meter I cap minus 3 meter j cap plus 4 meter k cap. So this is our vector equation. So by using this, we are going to find the value of this kinetic energy. So we are going to find the angle. What we are going to do, we are going to find the angle of these two kinetic energy. So if you want to find the value of the angle for these two change in kinetic energy, first of all, we have to frame the equation for the angle. So we can frame the equation of the angle from by using this equation of work done. So before that, I have to convert this vector form of the displacement equation in terms of magnitude. As we already know the procedure of finding the value of the magnitude of the d, which is equal to square root of 5 square 5 square plus minus 3 square plus 4 square. Clear? So we have to find the value square root of 5 square plus minus 3 square plus 4 square gives the answer of 7.07. 7.07. 7.07, and the unit for the displacement is meter. Now I'm going to apply this value in the formula of work done, which is equal to F d cosine theta, and we are going to find the value of the theta. So what I'm going to do, I'm going to first substitute the value here. So how I can substitute? Force value is 22 multiplied by 7.07 multiplied by cosine theta, which is equal to work done. Am I right? And we already studied the relation between the work done and the change in kinetic energy, because by using the equations, work done which is equal to change in kinetic energy, that means work energy theorem. So we already studied work energy theorem, W which is equal to change in kinetic energy. So in this place, what I'm going to do, I'm going to use change in kinetic energy here. That means my change in kinetic energy also have this value. So I can frame this equation in terms of change in kinetic energy. Therefore, change in kinetic energy, which is equal to 22 multiplied by 7.07 multiplied by cosine of theta. Clear? Now I'm going to keep this cosine theta here. I'm going to bring all these 22 multiplied by 7.07 to the left hand side of the denominator. By that, the equation becomes cosine theta, which is equal to change in kinetic energy over 22 multiplied by 7.07. Therefore, my theta, which is equal to cosine inverse of change in kinetic energy over 22 multiplied by 7.07. So now we have to substitute the value of the kinetic energy. So this is the equation for finding the angle. Am I right? So we already got the value of we already got the equation for the theta. So now the only thing we have to substitute the value. Better I can multiply this first. 22 multiplied by 7.07 gives me the answer of 155.54. By that, this equation becomes theta, which is equal to cosine inverse of change in kinetic energy over 155.54. So how we got? I just multiply this with this. Clear? Now we have to go for the question subdivision. So what is our subdivision here? We have to find the change in kinetic energy for these two values. The first part, we have to substitute the change in kinetic energy value as 45 joules. In the second question, we have to substitute the kinetic energy value as minus 45 joules. By that, we have to find what's the value of the angle. So in the first part, I'm going to substitute my change in kinetic energy, which is equal to 45 joules. So I have to take this value, I have to substitute the value here. By that, the theta, which is equal to cosine inverse of 45 over 155.54. So what will be the equation? Cosine inverse of 45 over 155.54 gives the answer of 73.18. So what's the angle? 73.18 degree. So this is the answer for the first part. What is the answer for the second part? We have to substitute the value of the change in kinetic energy as minus 45. So by that, what will be the answer? Change in kinetic energy, here they mention as minus 45 joules. By that, I have to substitute the value here. Cosine inverse of minus 45 over 155.54. Let's see what's the answer. Cosine inverse of minus 45 over 155.54 gives the answer of 106.81. So theta, which is equal to 106.81 degree. So this is the answer for the first part and the second part. In the first part, 45 joules leads the angle of 73.18, and in the second part, minus 45 joules gives the answer of 106.81. So there is a point. Clear? Okay. Third question. So in third question, some diagram is given, and this diagram indicates three forces acting on a block. So we have to find two answers, A part and B part. First of all, we have to read the questions very carefully. Figure shows three forces applied to the trunk that moves leftward by 3 meters. That means you have to see here, we have a block, we have a trunk materials which is shown as a block of material, and in this there are three forces acting. The first force has the magnitude of 5 Newton, and the most important thing, after you apply these three forces, which direction the object has the displacement? To the left direction. So the object is moving in the left direction. So better I can draw the diagram again. By that I can explain easily. So we have a block of material which is a trunk material, and here three forces acting. First force in the leftward direction, and then with respect to the horizontal, another force will be in this direction, which is F2, which is F1, and then the third force is exactly perpendicularly downward direction. So this is your F3, and here F2 have the angle theta. So now the most important thing, we have to identify the direction, because this question, in this question, the object, the trunk is placed on the horizontal, and by that the object has the displacement in the leftward direction. So better I can write here, this is the left direction, this is the right direction. Clear? So better we can take the right direction as positive x, and the left direction we have to take as negative x. Clear? And then the magnitude of the three forces are given. So what are the force? The magnitude of the first force is given as 5 Newton. The magnitude of the second force is given as 9 Newton, and the magnitude of the third force, which is equal to 3 Newton, and the angle for the second force is given theta, which is equal to 60 degree, and the displacement of the object is in the leftward direction, which is d, which is equal to 3 meter. Okay, now the most important thing, what I am going to do, by using the magnitude of the forces as well as the information given in the question as well as the diagram, based on the diagram, I am going to find which direction the force is happening, and I am going to frame all this in terms of vector form. Clear? So how I can frame? Better we can write the value here. My F1 force, so okay, let's start with the displacement. As they mentioned in the question, after you apply three forces, the object will move to the leftward direction. So when the object is moves in the left direction, it is in the negative x-axis. Am I right? So by that, my displacement has minus, because it is moving in the negative direction, minus of 3, and which is moving in the x direction, which has I cap, and the unit is meter. Clear? Likewise, F1 force, we have the magnitude of 5 Newton, but which direction the magnitude of the first force? Left direction. Again, it is negative axis, negative of x-axis. So minus 5 Newton I cap. Clear? And then second force we have. So for that, what we have to do? We have to find the value of the cosine component and the sine component. How we can find? Better I can explain from the diagram. So if you have the F2 here, we have two components. One is F2 sine theta, and this one is F2 cosine theta. By using these, I am going to find the value of this F2 magnitude in terms of vector form. So how we can find? By using the concept of third chapter. So what I am going to do? I am going to find the value of this F2. What is the value of F2? So for finding the value of F2, I am going to find F2 vector, which is equal to the magnitude of F2 multiplied by cosine theta I cap plus the magnitude of the F2 multiplied by sine theta j cap. If you substitute the value, what you'll get? F2 value here they mention as 9 Newton. So 9 cosine of 60 degree I cap plus 9 sine 60 degree of j cap. By that you will get the answer in terms of vector form. So better I can substitute the value. Let's we know what is the equation, final equation. 9 cosine of 60 degree gives the value of 4.5 Newton I cap plus 9 sine of 60 degree gives the value of 7.79 Newton j cap. So this is the equation. Clear? And then the third force is very easy, because it's exactly in the downward direction. So if this will be the positive of y, what is this? This one is the negative of y. So what is our third force? Our third force vector equation is given. We know the magnitude of the third force is 3 Newton. So 3 Newton j cap, clear, because it is moving in the y-axis. So we got the vector form of f1, we got the vector form of f2, we got the vector form of f3, and also we change the displacement in terms of vector equation as minus 3 meter I cap. Clear. Now what we are going to do, we are going to find the answer for the first part. What is given in the first question? We have to find the value of net work done on the trunk by these three forces. That means if you want to find the net force, first you have to find what is the vector, what is the work done based on first force, what is the work done based on second force, what is the work done based on third force. So we have to go for that equation. Better I can write all the forces one more time. Our displacement equation is given in terms of minus 3 meter I cap. Our F1 equation here they mention as, I think it's a magnitude they mention is 5 Newton, am I right? So it is moving in the negative direction. So 5 Newton I cap, and F2 we got as, better I have to go back, 4.5 Newton I, 7.79. Okay, better I can write it here. 4.5 Newton I cap plus 7.79 J cap, and the third force is the vertical force, downward direction, which has the magnitude of 3 Newton. So minus 3 Newton J cap. Now I'm going to find the value of work done for the first force. So what is the work done for the first force? The work done for the first force, which is given as F vector, that means F1 vector dot D vector. It's clear. So F1 vector here they mention as minus 5 Newton I cap, dot product with the D vector is minus 3 meter I cap. Now, when you just go for the dot product, the answer should be the scalar. Am I right? So the dot product gives you the scalar, the cross product gives you the vector. So here we have the dot product. So I have to multiply I cap with I cap. So I cap multiplied by I cap is I square, which is equal to 1. So minus 5 multiplied by minus 3, which gives the answer of minus 5 multiplied by minus 3. So 15 Newton meter, am I right? Or 15 joules is the answer for the first work done based on the first force. Likewise, we have to find the value of this W2 by using the second vector. So what is our second vector equation? 4.5 Newton I cap plus 7.79 J cap, dot product with the displacement, which is minus 3 meter I cap. Clear? Because every time we have to deal with this equation. So if you want, I can write it here. The W2, which is equal to F2 vector dot D vector. Clear? So here we got this equation. Now, brother, you have to see here, when you just go for the dot product, all the times I should multiply with I. And here we have I cap here, we have I cap here. But here in the second part, we have J cap. If you multiply J cap with the I cap, which leads to 0, because J cap dot I cap gives you the value of 0. So we no need to worry about the second part. Only I'm going to multiply 4.5 with minus 3. So 4.5 multiplied by minus 3 gives the answer of minus 13.5. So minus 13.5 Newton meter, or minus 13.5 joules. So this is the W2. Now I have to find the value of the third done based on W3, which is equal to F3 vector dot D vector. So therefore W3, which is equal to, my F3 is minus 3 Newton J cap, dot product with the displacement vector minus 3 meter I cap. So if you multiply, no use, because here j cap, here we have I cap. So even if you multiply, j cap dot I cap gives you 0. So the answer for the third work done is 0. So now we got three work done, W1, W2, and W3. Now we have to go for finding the net work done. That is our answer for the first part. So net work done, which is equal to W1 plus W2 plus W3. So what is the value of the W1? I think W1, we got the answer as 15 joules. 15 joules plus what is the W2? Minus 13.5 joules. And the third work done is 0. So 15 joules minus 13.5 gives the answer of 1.5. So what is the net work done? The net work done is exactly 1.5 joules. So this is the answer for the first part. Clear? Now we have the second part also, but we have to read what is given in the second part of the question. Does the kinetic energy of the trunk increase or decrease? So you have to give the theoretical answer. When you apply these three forces on this trunk, whether the kinetic energy increase or decrease. So for giving the answer for the second part, you have to use the work energy theorem, as we already studied that equation as W, which is equal to change in kinetic energy. Am I right? That means here we got the work done as 1.5 joules. That means the kinetic energy also increased by 1.5 joules. Am I right? So what's the answer for the B part? Yes. Here the change in kinetic energy will increase. Why? Because here we got the work done as 1.5 joules. So what's the answer for the second question? For the second question, the change in kinetic energy increases by 1.5 joules during the displacement. Clear? So this is the answer. So how we answer this? It's simple, because we already studied the work energy theorem. So if you have the work means, for sure there will be a change in kinetic energy. Because in the first part we got the work done as 1.5 joules, that means your kinetic energy, the change in kinetic energy also increased by 1.5 joules during this displacement. Clear? So the second part of the question is the theoretical question. Okay. Now we are going to answer the fourth question. What is given in the question? A spring and the block are in the arrangement which is shown in the figure, but here the diagram I am not enclosed here. So if you need, I can just draw the diagram. So what's the type of the diagram? So here, if you have a horizontal frictionless floor, and here we have a block which is exactly kept at 0, and we attach one end of the spring to the wall and we attach another end to the block. Now this is the diagram. So what is given in the question? A spring and the block. So here the block is this one. Better I can shade the block. So here this is our block, and the block is attached with the spring. When the block is pulled out to 4 centimeters, so what you are going to do in the second part of the diagram, you are going to pull the block. You are going to pull the block to 4 centimeters. That means if you consider this is 0, so better I can write 4 here. Okay. So by that my blocks will come here. And what will happen? The spring will expand it. Am I right? So when you place the block to 4 centimeter, the extension of the springs takes place. Clear? We must apply the force of magnitude 360 Newton to hold it there. So if you want to take this block to 4 centimeter, for that we have to apply the force of Newton 360 Newton. So initially you extend the spring to 4 centimeter, and then how much force of magnitude you applied? You applied the magnitude of 360 Newton. Now what you are going to do, you are going to find something, that means we are going to find how much work does the spring do on the block. But before that, we have to pull the blocks to x, which is equal to 11 centimeter. I will tell you the story about this x is equal to 11 centimeter, because we are not going to use this value for our calculation. Clear? So actually this question tells you about what is the formula for work done by the spring. We already studied the formula for work done by the spring, which is Ws, which is work done by the spring, which is equal to half k xi square minus xf square. So this is the rule. So now what I'm going to do, before we just go to the second part of the question, for sure we need the value of the k, which is nothing but spring constant. Once we found the value of the spring constant, I will explain the question from this line to this line. Okay, so first of all, we have to find the value of the work, the spring constant, k value. So for that, we have to use the Hooke's law, F, which is equal to minus kx, and here the minus is nothing but the restoring force which is happening in the opposite direction. So for this, what I'm going to do, I'm going to take the magnitude of the force equation, which is equal to kx. So by using this, I'm going to find the value of the k. Therefore k, which is equal to the magnitude of the force we applied over x. So I'm going to substitute the value. The magnitude of the force they mentioned in the question as 360 Newton over, and we extend the spring extended up to 4 centimeter. So we have to convert this to meter. Divide that number by 100, you will get the answer in terms of meter. So now what is the answer? 360 over 0.04 gives the answer of 9,000. What's the answer of the spring constant? The answer for the spring constant is 9,000 Newton per meter, because this is in meter. Clear? So now we got the answer for the spring constant k, which is equal to 9,000 Newton per meter. Now we have to go for the second part. Clear? In the second part, what they say, we pull the block to 11 centimeters. Again, you expanded to 11 centimeter. You expanded, because initially right now it's 4, am I right? So you expanded the spring to 11 centimeter and you are going to leave the block. So when you leave the block, what will happen? It will, because the surface is the frictionless surface, the block will oscillate between left hand side and the right hand side, am I right? So when you just leave, what will happen? So for that, you have to give more forces to expand it up to 11 centimeter. Once you leave, what will happen? Because of the restoring force, the block will move to the left hand side and it will accommodate one position, and then it will come to right hand side by means of expansion. So for that, it will accommodate two position, x initial as well as x final, am I right? So that means we are going to expanded the spring. This is just for getting the value of the initial position of the spring block as well as the final position of the block. Clear? So we have to expanded the spring to 6 to 11 centimeter, and then I am going to leave the block. When you just leave, what will happen? The spring will oscillate, the spring will move leftward direction and the rightward direction. By that, it will accommodate two position, x initial and x final. So that value is already given in the question. So in the questions, we are not going to use this 11 centimeter. Only we are going to deal with this value. That means this is the initial position, this is the final position. So you have four subdivisions. So what I'm going to do, I'm going to explain for only one subdivision, and the second part and the third part and the fourth part are exactly in the similar way. So here we have to keep our initial position as 5 centimeter. We are going to change only the final position. So the final position here is they mentioned as x value. Clear? So first of all, I'm going to use this value. My initial position is a 5 centimeter. The final position is exactly 3 centimeter. And then I'm going to use this formula for finding the work done by the spring. So what is the initial position? The initial position, which is 5 centimeter, if you convert in terms of meter, 0.05 meter, and your final position they mentioned as x, better I can write xf, which is 3 centimeter. So what's the answer? 0.03 in terms of meter. So this is xi, this is xf. Now I am going to substitute this value in the formula of work done by the spring. Work done by the spring, which is equal to half k xi square minus xf square. So first part of the question, I am going to substitute this value here. So what's the value? Half, and the k value just before we found as 9,000, half multiplied by 9,000 multiplied by xi square, which is 0.05 square minus 0.03 square. So let's see what is the answer. Half multiplied by 9,000 multiplied by 0.05 square minus 0.03 square gives the answer of 7.2 joules. How much? Exactly, we got 7.2 joules. Clear? This is the answer for the first subdivision. So likewise, you have to find the value of the second part and third part. So what is your initial position for the second part? 5 centimeter minus 3 centimeter. And third part, we are going to substitute initial position as 5 centimeter and the final position is minus 5 centimeter. Fourth part, we are going to apply the initial position as 5 centimeter and the final position as 9 centimeter. So likewise, what you have to do in the second part of the question, you have to deal with the same rule. But what's the value of the xi? In the second part of the question, your xi value is constant, 5 centimeter. What is your x of value? They mention minus 3 centimeter. Likewise, when you go for the third part, your xi value is a constant 5 centimeter and your x final is also minus 5 centimeter. You have to deal with the same rule. So try to find the answer, because why I have to repeat the same method again and same type of steps again and again, because I already explained for the first part. Please repeat the same thing for the rest of the question. Clear? So this is our last question of this chapter, and here we have 3 subdivisions. So we have to go very carefully and we have to read the questions word by word, line by line. A force F vector 3 Newton I cap plus 7 Newton J cap and 7 Newton K cap acts on 2 kilogram mobile object. So that means you have a block of mass of the object mass which is 2 kilogram, and for that this force is acting on this block of mass 2 kilogram. What is the force? The force vector is 3 Newton I cap plus 7 Newton J cap plus 7 Newton K cap. By that, this object moves from the initial position of di to the final position of df. So that means when you apply this force to this block of mass 2 kilogram, it has two position which is given as di vector, which is 3 meter I cap minus 2 meter J cap plus 5 meter K cap. This is the first position. And what is the final position? The final position is also given in terms of vector form, minus 5 meter I cap plus 4 meter J cap plus 7 meter K cap. So by using this, we can easily find what is the displacement. So the displacement which is equal to final minus initial. Am I right? So we are going to subtract the value of the final position with the initial position. So by that we will get the displacement vector D. Clear? So first question, we have to find the value of work done. So we know the formula for work done. So by using the formula W, which is equal to F vector dot D vector. Why I am just using this? I'm not using FD cosine theta, because here we have the force equation in terms of vector form and we are going to find the value of the displacement in terms of vector form. Once you know both are in vector form, we can directly go for the dot product. As we already studied, work is a scalar. So when you just go for the dot product, you will get the answer in terms of scalar, just a number. Okay. And then second part, we are going to find the value of power. So what's the power? Power which is equal to work over time. So once you know the answer for the first question, divide that value by 4 because they give the time interval as 4 seconds. So you'll get the answer. And the third part, we are going to find, sorry, the second part is the power for this interval. And what is the third part? We are going to find the angle theta. We are going to find the angle theta. So we just go one by one. By that, we will get the clear information. So the first question, we are going to find the value of the work done. For that, we need the displacement vector. But in this question, the displacement vector is not given. Only the initial position of the vector form and the final position of the vector form is given as a vector equation. So by using this initial and the final, I'm going to find the value of the d. So what's the formula? The displacement d vector, which is equal to df minus d initial. Clear? So what I'm going to do, I'm going to subtract this equation directly from here. So whenever you go for subtracting d final over d initial, always you have to subtract I with I, j with j, and k with k. Clear? So now 3 minus of minus 5. See, 3, because we are going to subtract, am I right? Sorry, from here, because d final minus d initial, that means minus 5 minus of minus of 3. So that means this is minus 3. Minus of 3 gives you minus 8 meter I cap. Don't subtract I with final, okay? Because the formula is final minus initial. And second part, 4 minus minus of 2. That means 4 minus minus of 2 gives you plus 2, am I right? That means the 4 plus 2, which gives you 6. 6 meter J cap, and here 7 minus 5, which gives the value of 2 meter K cap. So this is our displacement vector. Now I'm going to use the formula for the work done. As we already know, W, which is equal to F dot D. So what is our F vector? So I have to see the equation of the force. 3 Newton I cap, 3 Newton I cap plus 7 Newton J cap plus 7 Newton K cap dot product with our displacement vector minus 8 meter I cap plus 6 meter J cap plus 2 meter K cap. So what I told you just before, when you just go for dot product, all the times you have to multiply I cap with I cap, J cap with J cap, and K cap with K cap. Clear? So I have to multiply. 3 multiplied by minus 8. 3 multiplied by minus 8 gives you minus 24. I cap dot I cap gives you the value of 1. It's clear? So minus 24. Then 7 multiplied with 6, which gives you 42. So plus 42. And the most important thing, J dot J cap multiply with J cap, again J square, which gives the value of 1. Am I right? Plus 7 multiplied by 2, it's 14. And all these are in joules. Am I right? Okay, now we have to add 42 plus 14 minus 24 gives the answer of 32 joules. What's the answer? 32 joules. Please keep this information. I dot I cap dot I cap 1, J cap dot J cap 1, K cap dot K cap 1. Clear? So when you just multiply I with I, which will give 1. So 3 multiplied by minus 8 multiplied by 1. That means clear. So we got minus 4 plus 42 plus 14, which gives the answer of 32 joules. Brother, this is not J cap. This is the unit, J cap. So this is the answer for the first question. Clear? In the second questions, we have to find the power value of this answer. So as we already studied the formula, power, which is equal to work over time, and the time they mentioned in the question as 4 seconds. So and work value, I'm going to take from the first part. So what's the answer? 32 over 4. What's the answer? 32 divided by 4 gives you 8 exactly. So power, which is equal to 8, and the unit for power is watt. Clear? And then in the third part, we are going to find the value of angle. So for this finding the value of angle, what you have to do, you have to use our A dot B formula. What is the formula for A dot B? What is the formula for A dot B? A vector dot, sorry, A vector dot B vector gives you magnitude of A, magnitude of B, cosine theta. So I'm going to use this relation for this, but for today equation, we have in place of A vector, we have I vector, and B is nothing but D final vector. So we are going to apply this rule. Clear? So how I can write the equation? Di vector dot df vector, which is equal to the magnitude of di multiplied by magnitude of d final cosine theta. So what is our di and df? Better I can read the equation first. Di plus 3 minus 2 plus 5. I can use better I can write because it's really very hard. I will write di vector 3 meter minus 2 meter plus 5 meter minus 5 plus 4 plus 7. Okay, I can what is our di vector? Di vector here they mention as 3 meter I cap minus 2 meter j cap plus 5 meter k cap. What is your d final? Minus 5 meter I cap plus 4 meter j cap plus 7 meter k cap. These two equations are given in the question, so you can just go back to the question to see this equation. Brother, now what I'm going to do, I'm going to use this equation, use this vector here. So first of all, I'm going to find what is the magnitude of di, what is the magnitude of df. So we will get the answer. Magnitude of di, which is equal to square root of 3 square plus minus 2 square plus 5 square. Clear? This gives the answer of 3 square plus minus 2 square plus 5 square gives the answer of 6.16. The value here is 6.16 meter. And likewise, I have to find the value of D2 magnitude. So square root of minus 5 square plus 4 square plus 7 square. Clear? So let's see what is the answer. Minus 5 square plus 4 square plus 7 square gives the answer of 9.48. 9.49 meter. Clear? And then I have to find the value of A dot B. So what is the A dot B? Better I can find the DI dot DF here, because it's very easy to calculate here. So as I already mentioned, you have to multiply I with I. So 3 multiplied by minus 15, sorry, 3 multiplied by minus 5 minus 15 I cap dot I cap is 1, and here 4 multiplied by minus 2, which is minus 8 j dot J gives you 1, and likewise here 7 multiplied by 5 gives you the value of 35. What's the answer? And k dot k, which is exactly equal to 1. So minus 15 minus 8 plus 35 gives the answer of 12. So 12, the unit is meter square. Now what I'm going to do, I'm going to substitute this value, and this value in this formula. Clear? So once again I will write the formula, because we are going to find the value of the angle. So how I can write? We write di vector dot df vector, which is equal to magnitude of di multiplied by magnitude of d final multiplied by cosine theta, and we are going to find the value of the theta. So keep this cosine theta here and move this di magnitude and df magnitude to the left hand side of the denominator. By that your equation becomes cosine theta, which is equal to di vector dot df vector over magnitude of di multiplied by magnitude of df. Now we are going to deal with the angle. So I am going to keep this angle theta, which is equal to cosine inverse of di vector dot df vector over magnitude of di multiplied by magnitude of df. Clear? Now I am going to simply substitute the value, because just before we found the value of di dot df, we found the value of the magnitude of di, we found the value of magnitude of d, sorry, this is not d2, this is df final. Clear? So we already found all the values. Am I right? Now simply I'm going to substitute the value in the equation. So what's the value? Theta, which is equal to cosine inverse of di dot df, just before we found as 12. Am I right? 12 divided by the magnitude of di we found as 6.16 multiplied by what is the magnitude of df we found as 9.49. 9.49. If you want, you can just go back and check. 6.16 for di, 9.49 is for df, and then di dot df, which is 12. So exactly the values are correct. The only thing, we are going to find the value of angle. So cosine inverse of 12 over 6.16 multiplied by 9.49 gives the answer of 78.15. What is the angle? So 78.15 degree. So this is the answer for our third part. Clear? So in this question you should be very careful. Why? Because we are just substituting the value of the first question to the second question. Am I right? So that means if you made a mistake in the first part, it will affect the answer of the second part. And the third part, you have to deal with a dot product very carefully. Di dot df, and then magnitude of di, magnitude of df, and then you have to write the equation of the theta properly. Clear? So this is the answer for the last question.